if I may. That's 1 billion, right? Now this is a 1 billion. You might suspect raising numbers to the 1 billionth power gets you pretty big numbers. You're right, it does, except what number am I raising to the 1 billionth power? This is like 1.00000000000000001 or something like that, right? It's something that's essentially 1, just a hair bigger than 1. Even if I'm raising it to the billionth power, I'm not going to get a very big number, right? Because we said last class 1 to any power is 1, right? So we're only able to get just a little bit bigger than 1, and we get this. When I bump this to 9 billion instead of 1 billion, you know what happens? When I try to put 9 billion, it just doesn't have the memory to really calculate what that number is. And so it miscalculates. It just messes up. And so this is actually not true. It's not 2.7180 whatever. It turns out it would be a lot closer to 2.7182818 probably 8 instead of 7. Okay? The cap on this, that number that we're approaching, turns out to be one of the 5 most important numbers in all of mathematics. Okay? If I take this, and if I say, as n tends to infinity, as n just gets larger and larger and larger and larger, this number here heads toward 2.718281828 ... Okay? It turns out to be this irrational number. And it's not a repeating decimal. I know right now it kind of looks like 1828's repeating. It really doesn't. The next digits don't repeat. The repetition stops there. Okay? But we get this irrational number, and it's such an important number that we don't want to write it out all the time, so we give it a special character. We call it E. E for exponential. Okay? It's like pi. Remember how pi is 3.1415926, blah, 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 right? That number? Same thing for E. We have this number E, 2.7182, blah, 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 in between 2 and 3, that we use. And for those of you guys headed toward calculus, this is going to be a primo number. A very, 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 very important number. A really nice number. Okay, in fact. Okay? So, what does this have to do with our compound interest problem? Okay. Well, it turns out, if I do the same sort of thing that I was doing here, where I kept raising n bigger and bigger and bigger and bigger, at some point, when you go from compounding like 1 billion times in a year, 1 trillion times in a year, at some point, you're just compounding one moment after the next, right? Like, if you took, well, no, let's not do it. But imagine taking a year and dividing it into 1 billion or 1 trillion pieces. It's not a very long segment. It's less than a second. It's like microseconds, nanoseconds up to at some point, right? Okay. So when we do this, when we keep compounding over and over and over and over and over and over again, we say we are continuously compounding. And I don't want to erase it, I'm out of room. If I have continuously compounded interest, we actually end up with a different formula. Okay? The formula we end up with is still A, the same A. And this is going to equal P, same principle. But this time, instead of being like 1 plus whatever, it becomes that number E that we're talking about, that 2.71828, that constant. That E raised to the R times T power, the rate times the time. And, some students call it like PERT, something like that. But this is what we get when we do continuously compounded interest. Okay? All right, I'm going to let you write that down, but then I got to pull the screen back down.
And the E's on the calculator?
The E, yeah, well, I'll show you where the E is on the calculator in a second. There's two places you can get it.
Let's say we're just writing it out though, would we go 2.718?
No, you would write E.
Sorry.
You just write E. And you can just write E because, as Tara's pointing out, it's on the calculator. Okay?
Are these problems that, like, whenever we can plug in the APR, everything, then these obviously will be problems we don't have to show our work, as long as you get the formula, then you can plug it in?
Yeah, the smart thing to do on the test, since the calculator does most of the arithmetic, is on your paper, write down what you plugged in your calculator. So I can see, oh, they knew what they were supposed to plug in, they just messed up plugging in or something like that. Yeah. Okay, so here's where we're headed with this. We're going to go back to this problem and say, what if we had continuously compounded interest? Okay? When you have continuously compounded interest, that's the max you can get. As long as you keep the principal, the interest rate, and the time the same, that's like the maximum amount that you can get just by changing how many times you compound. You can't compound more often than continuously. Okay? So, where is E on your calculator? Two places. One place you can get that E.
I have a question. So the word problem would say compounded
Continuously.
It'll say that.
You'll
in
say
the word
continuously.
problem.
Yes, continuously be the keyword. Okay? One place you can get E on your calculator is if you hit second divide. It's right there. There's your E. And like I told you, it's going to be 2.718281828, blah, 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 blah. But that's probably not going to be the place where you use it. Almost every time you use E, you're almost always raising it to some exponent. So to get to that E, if you hit second ln, it's the button right underneath log on the left-hand side, y'all see that E to the x? When I hit second ln, that's going to be E automatically raised to some power. Okay? And that's more often than not the E that you're going to use on the calculator. Okay? So, so that number there was compounded monthly. What do I get by compounding continuously, using the formula that we just wrote on the board? If this was compounded continuously, then it's the principal $2,000 times E to the, what was the interest rate? Yeah, 0.04 times, what was the time? 3 years. So we got 2,000, second LM. And notice it automatically opens up the parentheses for me, right? How cool is that? Thanks, Texas Instruments. And there it is. It's a sad day. I really owed some officers that money. They're going to break my knees because I couldn't get that last penny. They couldn't wait a day. All right, so $255.99 was the max I was going to get out of this. Nobody's got a penny I can borrow? All right.